In this video, I'm going to look at two properties of functions, increasing and decreasing and extrema. So when you have a function, one question we can ask is where is the function going up versus going down? And if you think of an example like if this represented profit, we would want to know when the profit was going up or increasing or decreasing. And there's lots of examples of applied functions where we want to analyze this property. And the key here is that when we talk about intervals of increase and decrease, we have to specify a direction. So when we say a function is increasing, we mean that as you move from left to right, or as the x values get bigger, the function is going up. So here, as x gets bigger, f of x is increasing on the following intervals. Well, if I follow along the graph, we see that actually at first it's dropping and then it kind of flattens out and it starts increasing right here. Now that's an x value of 3. So I'm going to start my interval at 3 and say, okay, it increases from 3 up until this point here, which is 5. Now increasing and decreasing intervals are always open intervals, meaning that we do not include the endpoints. They have the parentheses. And that's because if I look specifically at the point x equals 3, the function's not really going up or down there. It just is a point. So we say it's increasing kind of between 3 and 5, but not at the endpoints. On this graph, that's the only place this function is increasing, so then we would look at decreasing. This function is decreasing right away, so I would start my decreasing interval at -infinity, and it stops decreasing, looks like at -1. And then it also decreases on the other end, so starting at 5 and going on to infinity. And the last property, if a function isn't going up or going down, then we say that the function is constant. In this graph, it looks like the function is constant in between x equals -1 and x equals 3. We don't actually see constant intervals very often on our normal functions, but it's worth mentioning here. Going along with increasing and decreasing, we have some sort of special points. So in this case, we have a function that is decreasing, and then increasing, and then decreasing, and then increasing. Every time it flips like that, we get what's called either a relative maximum point or a relative minimum point. So for example, the point B is a relative minimum. And what this means is that this is the lowest value that our function has, at least nearby on the graph, right? It's kind of a valley in the graph or a low point. Now, B is not actually the lowest point on the whole graph because we do get lower over here. D is what we would call an absolute minimum. We can also call a relative minimum a local minimum and an absolute minimum a global minimum. They're both minimums, it's just that D is actually the lowest point anywhere on the graph, whereas B is just a low point. Similarly, C would be called a relative maximum. And these topics kind of go together because increasing and decreasing is linked to maximums and minimums. You can only move from something that's increasing to something that's decreasing if you go through a maximum, and similarly for minimums. So some of the problems you'll have on the worksheet, I'm giving you the equation of a function, and I want you to find where it's increasing, where it's decreasing, and any maxes and mins. Now since we don't have a graph, we're going to have to actually generate our own graph. And you can do this on the calculator. So I would first have to graph the function. So first we go into our y equals, which is the button up at the top left. I'll go ahead and clear out what I've got there. And then you want to type in the equation of what we want to graph. So here I'm going to type in x minus 2. You get your x from this button kind of in the middle here. It says xt theta n. That's the variable button. For squared, you can either use the squared button on the left-hand side, or you can use the up caret and 2. Right? You can use that for other powers. Plus 3. And then I'm going to graph it. I've graphed other stuff on this calculator before, so just to make sure that I'm in a normal window, I'm going to go to the Zoom menu right in the middle at the top here and go to Zoom Standard. This is where most of our graphs start off. This actually gives us a pretty good picture of the graph. We see that this is actually a parabola or a quadratic graph. And we can see that it's kind of coming down, it reaches a low point here and going back up. So just from this graph, we can see that we have a relative minimum. What I'm not sure about is the location. Now we'll figure out how to find a minimum of a quadratic without having to use the calculator in a later section, but we can use the calculator here. So I'm going to use this second button, the yellow button, and then go to the button that says Trace, and it says Calc right above it in yellow letters. So that's the Calculate menu. And there's a bunch of different options here, but one of them is minimum. Now here we're finding a minimum. Finding a maximum is the same process. You just want to pick whichever one makes sense for your graph. So I'm going to choose minimum. It asks for a left bound, which means I'm going to use the arrows just to move the cursor somewhere over left of the point that we know is the minimum. So this one will work. The right bound, I'm going to scooch the cursor over to the right of the minimum. And then guess you can just get the cursor kind of close to the minimum. So this one tells me the minimum is the point 2, 3. This is a minimum value of 3, right? 3 is the lowest y value we get, in this case on the whole graph, and this occurs when x equals 2. Because we know this point, we also know the intervals of increase and decrease. So f is increasing. Remember the rule, we have to go from left to right. A lot of people look at these parabola graphs and think, oh, they're pointing up on both ends. That means it's always increasing. But we have to be going from left to right. So if I go left to right on the graph, it's actually dropping at first, and then it increases once we go past that minimum. So this is increasing from 2 on to infinity. F is then decreasing the rest of the time, so starting at negative infinity up until 2. So by graphing the function and identifying the min or the max, or maybe more than one, we can also figure out those intervals of increase and decrease. Finally, you can also use this to find minimums in applied problems. So again, imagine this quadratic here is, for example, a cost function. Often you want to figure out what is my minimum possible cost in a business scenario. So in this case, and the numbers don't really make sense here, but if this was our cost function, the minimum cost would be 3, maybe dollars, and that happens when x equals 2.